Hey everyone, so this is Mohamed Labouardy. I'm the author of Pipeline as Code, and in this demo I will try to show you how you can build up a CI/CD pipeline from scratch for a React web application. So before we get started, there is a special discount for my book on mining, so I will drop out the discount code on the chat afterward. So make sure to check out the book. On this live session, I will be trying to cover one of the topics I'm covering on this book. However, if you want to get deep dive into CI/CD and how you can build your own for your distributed web applications, make sure to check out my book on mining. Also, all the resources and the code source that I will be using on this demo will be available on my GitHub account. I will also share my GitHub repository afterward, so you can try everything that you can see right now on your local machine. So with that being said, let me show you the application that we'll try to integrate during this live session. So I have already built a web application using the React Web Framework. This application is simply a search engine for movies. So basically you have a search bar. On this search bar you can search for a movie, and basically the web application, it uses the movie database API, which is a public API similar to IMDb, which allows you to search for specific movies based on keywords. So this is what's happening behind. I will show you the code source later on. However, it's not the main topic of this session, so I will go through the source code quickly. However, you will find all the resources on the GitHub repository afterward if you want to get deep dive into the web application architecture. But basically it's quite simple. So we have just a search bar, and on each keystroke we call the movie database API to fetch the results, and then we just display the results on the page. So basically this is the application that we'll try to integrate during this live session. So before we start the integration part, let me show you the CI server that we'll be using during this demo. So the CI server will be simply Jenkins. So I have already deployed the Jenkins cluster in advance. So the Jenkins is basically split into two main components. So you have a master component and the workers. The master component is simply a server which exposes the web dashboard that you can see right now. And then you have workers, which are simply nodes on which the jobs will be built on. And you have the master, which will be responsible on scheduling the build jobs on these workers. So I have already deployed the Jenkins cluster on my AWS console, and I have already set up all the CI environments in advance. However, you will find all the resources that I have used to deploy this cluster on the book GitHub repository. So for instance, if you go to, I guess, chapter 5, so here you will have all the Terraform resources that has been used to deploy this Jenkins architecture. So basically, to deploy this architecture, I have been using Terraform, and I have written a Terraform template for each component. So for instance, here you have the template file responsible for deploying the Jenkins master. So Jenkins master is simply an EC2 instance in this case, and I have configured a security group to allow inbound traffic on port 8080, which is the port on which the Jenkins dashboard is exposed to. And I have also configured a load balancer on front of my EC2 instance to expose the web dashboard. So I don't want my EC2 instance to be exposed to the public. So that's why I'm having a load balancer in front of my EC2 instance. That way I will allow only the inbound traffic on port 8080. And I have done the same also for the Jenkins workers. So the Jenkins workers are simply behind an autoscaling group. So I want my workers to be scalable based on the numbers of jobs or the workload that we are trying to integrate on Jenkins. So instead of having a fixed number of workers, here I'm setting up an autoscaling group. An autoscaling group basically in AWS is a number of instances in which you define a minimum and a maximum. So here you have a minimum of 2 instances and a maximum of 10. And to add or remove workers, I have defined some CloudWatch policies to trigger a scale in or a scale out events. So basically, if the CPU utilization of my Jenkins workers is higher than 80%, I will add a new Jenkins worker to the cluster. And if the CPU utilization is less than 20%, then Jenkins worker will be removed. That way we'll have always a self-efficient and cost-effective Jenkins cluster. So for this demo, I have started with 2 workers. However, if we start building or integrate more applications and having a heavy project, a new worker will be added automatically to the Jenkins cluster. So as you can see here for this demo, I have already created my Jenkins cluster and I have already two EC2 instances running as a workers. So with that being said, and now we have our Jenkins cluster is running, let's start the integration process of our React web application. So for this web application that I have already written in advance, let me show you the source code first, and then we'll start the integration process. So here I'm using Visual Studio Code as my editor, and I have already created a React web application, and I have defined some components. So basically, if I show you the application skeleton, so it's basically we have a search bar component, and then we'll look through the movies attribute, and then for each movie we'll just display the movie component, and we pass the movie object to this component. And to get the list of movies, I'm just using the MovieDB API, and this API will return a list of movies. Once I get these results, I pass them to the movies attribute, and from there I show them on the page. So basically it's simple web application. So to start the integration process, what we need first is to create our remote repository in which we store our application source code. So for this demo, I will be using GitHub. However, you can use any other system control, versioning control system, or you can use something like GitLab or Bitbucket, or even as SVN repository. So just give me a few seconds. I think we are back. So sorry guys for the interruption. So basically, to go back to the question regarding CI, GitLab CI and Jenkins, I have been using GitLab CI in the past, I think it's a good choice if you are already using GitLab as a remote repository, because you have a lot of stuff integrated out of the box. Basically, you have already an integrated registry for your Docker images. You can also use Docker as an agent to run your build jobs. So it's also a good choice if you are already using GitLab to store your source code. However, once you start uh, having a lot of projects and a lot of pipelines, and if you want to have more flexibility to integrate with external tools, it might be a roadblock on the long run. That's why some cases an open source solution or something like Jenkins or others might be a good choice, even though there is a lot of learning curve and operational overhead that comes with the usage of Jenkins. So let's go back to GitHub and let's create a repository for our project. So this repository, I will be call it movies aggregator. So for now, I'll set it as a private repository, but once I'm done with the demo, I will set it to public, and I will share the URL on the Twitch feed, so you can test out everything on your machine. So now I will go back to my editor, and then I will add a new origin. So I can now push everything to the master branch. So for now, I will go with the single branch. However, in a few minutes, we will see how you can use an advanced branching model like GitFlow. So if I refresh this page, I should have my application code source. So now we have our remote repository with all the source code of our web app. To integrate this application to Jenkins, we need to write a Jenkins file. So basically, a Jenkins file is just a template file in which you write all the stages or all the steps that tells Jenkins what it need to do. So basically, all the commands that you want to be run on your remote repository, you describe them on this Jenkins file. So there is two ways of writing a Jenkins file. You can use the scripted or the declarative approach. For this demo, I will be using the scripted approach. However, on my book, I have covered both approaches. I prefer scripted approach because it gives more flexibility, and if you have already been a developer in the past, and I think it's easier to adopt this approach, because it's the same concepts that you have seen in languages like Java or Groovy, and all the concepts that you have been using in these languages can be also used while writing a Jenkins file. So I will write a Jenkins file, and on this Jenkins file, first I will describe the machines on which I want my CI/CD pipeline to be executed. To do so, I need to define a node parameter, and on this node parameter, I need to give the label of the machines on which I want the pipeline to be executed on. So for this demo, I have already created the Jenkins workers, which are simply some EC2 instances. And on these EC2 instances, I have given them some labels. So let me first connect to my Jenkins dashboard. So as you can see, for this Jenkins worker, I have given it the label workers. So that way I can assign build jobs to this EC2 instances, to this EC2 instance using the workers label. So here I will define the node on which I want my build job to be executed on as workers. And then on this node section, I can here define the stages that I want to be executed on Jenkins. So the first stage will be the checkout stage, which is basically responsible of cloning the GitHub repository. So this is the first stage that will be running on Jenkins. So I will just commit this stage to the master branch. Now I can go back to Jenkins and I will create a new job for my application. So for this application, I will create a job called Movies Aggregator. The type of the project will be a multi-branch pipeline, because basically we want to support multiple branches, and we'll be using multiple branches on the project. So it will be easier to integrate these branches easily with this type of configuration. And basically multi-branch pipeline will simply tell Jenkins to scan your GitHub repository and scan all the branches that are available looking for a Jenkins file. So each time there is a Jenkins file available on a branch, it will be detected and Jenkins will create a new sub project for the branch that has been discovered. That way you can easily integrate your GitHub branches or Git branches without creating or duplicating job configurations every time you create a new branch. So for the source of our code, for now we are using GitHub, so I will be using the GitHub plugin. I have already created the credentials, and for the repository URL, I will just copy the clone HTTPS URL. You can also use SSH if you want. For the discovering behaviors, I will set it as default, but we'll see later how you can customize it. And if I click on apply and save, as you can see, Jenkins has scanned the GitHub repository and has discovered that there is a master branch that contains a Jenkins file. So it automatically created a new sub project for the master branch, and then it executed automatically the pipeline. So as you can see, for now we have one single stage, which is the checkout stage. So if we click on this stage, you can see that the project has been cloned and it fetches the latest changes on the GitHub repository. So basically this is a simple pipeline, so we can go further and start integrating our application. But before we do so, I want to show you how you can integrate Slack notifications within your CI pipeline. And to do so, I will be using the Slack notification plugin. So here you can find this plugin and all the available plugins of the Jenkins community on plugins.jenkins.io. I have already installed the Slack notification plugin, and I have already configured my Slack workspace to receive or to allow Jenkins to send me notifications. And I have also created a token that I have configured on the Manage Jenkins Configure System section, and then on the Slack section I have defined the workspace and also the Slack token. Here I have defined a default channel. However, you can override the channel in which you want to send the notification during the CI pipeline. So to send the Slack notification, I will be using the cell called notification Slack, and this instruction basically it's a custom function that I have written in advance, which uses the Jenkins Slack plugin method. So basically this method, let me copy paste the method. So basically this method, it takes the build status as a parameter, and based on the build status it will write a message, and then it uses the Slack send official method, which is the method provided by the Slack plugin that we have installed on Jenkins, to send a message to the right Slack channel. In this case, it will be notifications channel. And as you can see, for the message that we'll be sending, so basically we send the job name, the status, and also the build number. So for the build number and job name, we are using the default environment variables that are exposed by the Jenkins job. We are also sending extra informations like the commit message and the commit author. And the commit message and the commit author, as you can see, they are custom methods. So there are methods that I have also written in advance. So let me show you how they looks like. So this method, for instance, the commit author, the commit message, and commit ID. So basically here I'm using some basic get commands to parse the get commands output to fetch the message and also the author name. So that way I will be sending a Slack notification with the customizable and personalized message about the job that has been built by Jenkins. And now if we integrate this to the remote repository, we should have a new Slack notification. So let me click on scan repository now to first Jenkins to scan repository, and if there is a new changes, the sub project for the master branch will be executed. So now if we click on console output, we can see that a Slack notification has been sent. So let me show you the Slack message. So I'm just opening my Slack. So as you can see, this is the Slack message that has been sent to this notifs channel. So here you have the name of the job as well as the branch, the status, the build ID, the message, and the author name. You have also the URL to access directly the job on Jenkins. So now we have a simple stage which check out the source code and then it sends a Slack notifications. So what we can do next is we start running some tests on our project. The first type of test that we'll be running is quality test. So for this web application, I will be using a code linter. I have already configured the project to use OSLint, which is a famous linter for JavaScript. And I have configured some linting rules for my web application. And to start the linting process, I just need to run the npm run lint command. So let me show you the output of this command. So basically, if I click on npm run lint, it will check all the JavaScript files, looking for errors or rules that are not respected, such as unused variables or wrong parameter, etc., which is a good thing because it allows you to identify potential bugs and errors. So it is always a good idea to have some kind of code linter within your CI pipeline. So to integrate this command on our CI pipeline, every time we push new changes to the remote repository, we need to run npm run lint command. However, to run this npm run lint command, we need to install Node.js on our workers. So we can do that. However, it's not scalable because we don't want to install a runtime environment for each project that we will maybe try to integrate. So imagine you have multiple projects. Each project is written in a different language or a different framework. If you want to integrate all these projects on your CI server, you will need to install the appropriate environment, the appropriate versions and dependencies, which requires a lot of operational overhead and maintenance. And to avoid that, I will be using Docker. So basically, I will be running all the tests of my CI/CD pipeline within Docker containers. So to do so, I will need to write a Dockerfile. So because this Dockerfile will be responsible for running the test of my web application, so I will call it dockerfile.test. And on this dockerfile.test, I will be using Node.js latest stable version. However, you can also specify the tag or the version of the Node.js image that you want to use. However, for the simplicity, I will be using the latest stable version. However, you can define the version that you want to use by going to Docker Hub and by picking the right version. And then I will define a working directory, and then I will copy the package log.json and package.json to my container. Then I will run the npm install command to install all the dependencies, and then copy all the source code to my container. So basically, the reason why I'm copying the package log and package.json before the source code is just to use the caching layer mechanism of Docker. So we know that dependencies are rarely changed or upgraded. However, the source code will be changed frequently. So to avoid to rebuild the image every time, I have placed the dependencies on top before copying the source code. That way, this 5 instructions will be reused with the caching layer of Docker. So the only thing that will be rebuilt every time we type docker build command is this instruction. So with that being said, now we can save this file, and then we can write a new stage, and this stage, let's call it quality test. And on this stage, I will be typing the steps or the commands that will be executed on the quality test stage. So the first command will be building a Docker image from dockerfile.test. So I can use docker dsl instruction. So basically, this command will take 2 parameters. The first one will be the name of the image that we want to build. So here I will be using a variable called image name, and I will define this variable on top. So for this image, I will call it movies aggregator. And then I need to give the location of the Docker file that I want to use. So because we are not using the default Docker file, that's why I'm specifying the F flag to override and to pass the right Docker file. And then we need to specify the context. And then once this image is built, we need to run a container from this image. So we'll use docker run rm command. So here we'll use once again the name of the image. However, while running the container, we'll use the npm run lint command. So basically what we are trying to do is to building the Docker image, and then we run a Docker container and we pass the npm run lint command. And by running the npm run lint command, we'll be executing the OS lint code linter. So once again, I will push these changes to GitHub. So if I click on build now, as you can see, the Dockerfile.test will be used to build a Docker image. So while the container is being built, let me show you the Ec2 dashboard, where I have created my Jenkins cluster. So basically, as you can see, I have a Jenkins master and 2 workers, and these instances are deployed inside a VPC. So that's why I'm using a Bastion host to be able to SSH to my instances if needed. I have also deployed a Sonarcube server. So all the Terraform templates that have been used to deploy this architecture are available on this repository. So you have different chapters, and on each chapter you will find the resources that has been used to deploy specific components of this architecture. So let's go back to our CI server. So as you can see, our image has been built, and then we have executed a Docker container and we passed the npm run lint command, and this command has executed the OS lint command to start the code linting process. So as you can see, now we have 2 stages. So let's go further and let's now run some unit tests. So because I'm using a React web application, so I have already defined some tests, and this test has been written using the JS framework. So to trigger this test, we need just to run npm run test command, and by running this command, it will trigger all the unit tests that has been defined on this project. So as you can see, when we click on npm run test command, we have a listener which is subscribed to the test files. So every time you change the .test.js files, this command will be executed. However, we wanted to exit and give us control to the console, especially when this command will be executed on Jenkins. And to do so, we need to configure the package .json and override the test script command to tell it to exit once test has been executed. That way it gives us control to the terminal. So now if we run once again npm run test command, as you can see, the test has been successful, but however this time we have access to the terminal. So with that being done, we can go back to our Jenkins file, and now we will write another stage to trigger unit tests. And basically it will be the same process for quality tests. So the only thing we need to do is instead of running npm run lint command, will be running npm run test command. So let's test it out. So as you can, before we trigger this these changes, as you can see, for now we are triggering the build by clicking on the build now button. However, we want the build to be triggered automatically every time there is a new push event. So what to do so, we need to configure a webhook on our repository, and it's quite simple. You just need to go to the GitHub repository of the project, and then you need to create a new webhook, and then you need to define the URL that will be used, which is the Jenkins URL /GitHub hyphen webhook. For the content type, you can leave it as default. You can also define a secret if you want to secure the communications between your Jenkins and GitHub. And for the events, you can configure the type of events that you want the webhook to notify Jenkins for. So for simplicity, I will let the webhook notify Jenkins on all the type of events. And if you click on add webhook and go back again, you can see that a new event has been sent to Jenkins. So now if we change the README, for instance, as you can see, now a new event will be sent to Jenkins and a new build will be started automatically. So as you can see, this build has been started automatically. So we have an error. So let's see. Yeah, so it's just a typo. I have forgot to add a single quote. So hopefully this time it should be working. And once again, a push event will be triggering the pipeline. So if we click on this build, so while the pipeline is being executed, let me show you how you can take unit tests further. So for now, we are just executing unit tests. However, it might be also helpful to have some kind of coverage report. And fortunately, when you are using something like JS framework or Babylon or Istanbul or other frameworks, they come out of the box with the coverage report support. So for our example, we are using the JS framework. So to generate the coverage report, I just need to pass the coverage flag. So this time, if I write npm run test command, a coverage report will be generated as well. So as you can see, we have a coverage report on the terminal, and we have also a coverage directory on which we have an HTML format of our report. So we can take our Jenkins file folder and tell Jenkins to consume this HTML files to generate UI visualization of our coverage report. And to do so, we'll be using Jenkins plugin. So before we go and show you how we can use the Jenkins plugin for the coverage report, as you can see, the Npm Run test has been successful and all our unit test uh, has been passed. So now we have 3 stages. So for the HTML report, so if you type HTML plugin, so here we'll be using the HTML publisher, and because you are using Jenkins file, so we cannot trigger this generation of report with the UI. That way we'll be using the DSL format, and the DSL format is this one. So I will be copy and paste it here. So let me also enable the Groovy autocorrelation, because basically a Jenkins file is written in Groovy, so it's also helpful to install Groovy extension on your editor. That way you can easily debug and write your Jenkins files. So I will need just to override some variables. So the first one will be the report directory. So for the report directory, I will be defining the full path by using the pwd command, which gives the current directory path. And the coverage report is stored on the coverage directory, and it's under this subdirectory, so I need to specify it also. And the name of the index file is index.html, so I need to change that as well. For the report title, I can remove it, and for the report name, let's call it coverage report, and that should be it. So now if we push this to GitHub, and go back to the Jenkins dashboard, we should see that a new event has been triggered and the coverage report will be generated, and then it will be consumed by the HTML publisher plugin. So while the stages are being executed, let me check the chat to see if there is any question. So now the npm run test command is executed, but this time with the coverage flag being enabled, so you can see the coverage reports on the text format, and then you can see that the HTML publisher plugin has consumed the coverage report directory. So now if we go back to our sub project, we can see now we have a coverage report item on the left sidebar, and if we click on it, we will be redirected to a new page on which we can see the percentage of the coverage of test of each file. We can see the percentage by statement, by functions or lines, and we can explore each file. That way we can see which methods or files should be covered by upcoming unit tests. So this is a simple way to integrate the HTML publisher plugin and to generate coverage report. Now we can take this further, and instead of using a simple code linter, we'll be using an external service to continuously inspect our web application, looking for bugs, and also to improve the quality of our source code. And one of the famous services that exists on the market that can help you continuously improving your quality of code is Sonarcube. And if you remember, I have already deployed Sonarcube in advance on my AWS account, and the resources that has been used to deploy this Sonarcube are available on this GitHub repository. So you have all the template file for Terraform and also the templates used to bake the Sonarcube machine image. So make sure to check it out. It takes you few minutes to bake your machine image and few seconds to deploy a Sonarcube server with Terraform. I have already done some tests with the previous application, so I will show you how you can integrate your React Web application as well with Sonarcube. So before we do so, we need to create a configuration file to tell Sonarcube how to scan our web application, and this file is called sonar.project.properties, and the content of this file is the following. So basically you need to specify a unique identifier and also the project name and the files that you want Sonarcube to not scan. So for instance, for this project, we don't want Sonarcube to inspect the node modules, and we want it to scan the SRC file in which we have all the source code of our application and also the test files. So with that being configured, we can head back to our Jenkins file and we can create another stage to trigger Sonarcube. So this stage, I will be calling it static code analysis. And to trigger Sonarcube, we need first to inject some environment variables, and this environment variables contains the URL of Sonarcube as well as the credentials, and I will show you in a few seconds how you can configure these credentials on Jenkins. So to trigger the scanning process, we need to use this utility called Sonar-scanner. I have already created this utility on the Jenkins workers while baking their machine images. So let me push this to Jenkins, to GitHub, sorry. So now if I go back to Jenkins, a new event will be triggering the pipeline. So let me show you first how we can configure Sonarcube. So I have already running Sonarcube server on an EC2 instance, and then I have defined a Sonarcube configuration on which I have defined the Sonarcube URL as well as an authentication token. And to inject these variables, I have used the Sonarcube ID. That way, on the Jenkins file, I can inject these informations by calling with Sonarcube environment method and the Sonarcube ID as a parameter. So now if we go back to our pipeline. As you can see, the static code analysis was successful. And if we go back to Sonarcube and refresh, we now have a new project on Sonarcube, and we have a bunch of metrics like the duplications of code, the security vulnerabilities, number of bugs and securities, measures, and a bunch of other informations. So for now, there is not a lot of useful information because the project is quite small. However, in the long run, once you will start having complex web applications, you will start having some useful metrics that will help you in improving your quality of code. So you can also access the project directly from the Jenkins dashboard by clicking on the Sonarcube item from the sidebar. So we have seen how you can write and trigger some tests within your CI/CD pipeline with Docker containers. Let me show you now how you can build and compile your application. And to build our application, we'll be using Dockerfile. So we'll be writing Dockerfile, and on this Dockerfile, we'll be using the multi-stage feature build, which is simply allows us to create lightweight image. So first, I have declared Node.js as a base image, and then I will be writing the classic commands that you have seen so far, which is defining our workspace directory, copying package log and package.json, then running npm install, then copying the source code to the container. The additional command will be the running of npm run build command, and this command will basically create all the static assets of our application. So at the end of the day, our single web application, which is a static web app, so it's just a bunch of HTML files, JavaScript, and CSS. So the npm run build command will create this will create a directory with all the assets needed to run our application. So as I said earlier, we'll be using the multi-stage build feature of Docker. So instead of running these files on an Nginx on the Node.js base image, what we will do is we will copy the assets files from this stage, and then we'll put it on an Nginx Alpine image. That way you will end up with a lightweight image that has only the necessary files to serve your web application. So you will reduce a lot the image size. So I will need just to delete some default files from the Nginx base image, and then I will copy the app build folder from the builder stage, and then put it on the user /share/nginx/html. I will expose the port 80. However, it's optional, it's not required. And then I will set the entry point to be Nginx, and that way we'll start our web server on port 80. So basically this is a basic Docker file which simply use the multi-stage feature to build the web application. and build all the assets, and then it copy the assets from this builder stage and then put it on an Nginx Alpine lightweight image. So now we can define a build stage, and we can now use the docker.build command. So as you can notice, I didn't specify the second parameter because by default it will be using the Dockerfile. However, because on the test I have been using Dockerfile.test, that's why I have overridden the default file by providing the second parameter. And just to avoid the conflict, I will be adding as a suffix the test. That way we can make a difference between the test images and also the image that has been used to build our web app. So with that being said, we can now push these changes to GitHub. So once again, if I go back to Jenkins, a new event will be triggered and the pipeline will be executed. You can also open Jenkins on the Blue Ocean mode, which gives you a better appealing and visual UI, on which you can easily track all the stages and see the logs for a specific stage easily by clicking on the right dot. So as you can see, now the build stage is being executed. So the npm run build command is running and it will generate all the assets, and from there we copy the app/build folder to /user/share/nginx/html on the nginx image. So as you can see, now we have our Docker image for our application. What we can do next is store this image on a private registry. So because I'm already using AWS, so I'll be using a service provided by AWS, but you can use something like Docker Hub or deploy your own private registry. So I'll be using Elastic Container Registry, which is a service provided by AWS, which allows you to host your private or public Docker images. So I'll be creating a repository for my project. So it will be a private image. So the name of the registry of the repository will be the name of my image. And then I will click on create repository. So now I have this repository in which I can store the different tags and version of that I will be building through the development cycle. So I will be copy the URI of this repository, and then I will define a registry variable and a region variable. So my infrastructure is deployed on the Frankfurt region, so that's why I'm defining East Central one as the region. However, you can override this variable and the registry URI based on the region that you are using. Then I will be defining a push stage, and before we push this image to the Elastic Container Registry repository, we need to sign in with the AWS CLI to be able to interact with the registry. And to do so, we'll be using the AWS ASRR command, and this command can be found by selecting the repository and clicking on view push commands. And here you can see the command that you need to type to get a temporary password or token that you can pass to your Docker login command. That way Docker push command will be able to push the image to the private registry. So I will be typing this command here. So AWS Elastic Container Registry get login, no include email, then the name of the region, which is a variable, and then I will be using pipe2 just to hide the token that will be generated by this command. Then I will be using Docker with the registry method, and I will give it as a parameter the registry URI, and inside this section I will be using Docker image name, and I will push my image to the registry. So we need to define a tag. So for simplicity, I will be using the commit ID. So I have already a method which gives me the get commit ID. However, you can use something advanced like semantic versioning if you want. So as you can see on the push stage, we'll be interacting with the Elastic Container Registry to get a token and sign in with it with the Docker login command. And then we'll be using the Docker image.push to push the image that has been created to the registry and tag it with the commit ID. So once again, let's push this to GitHub. So now if I go back to Jenkins, I will be having a new event. So as you can see, a new event has been triggered, and the pipeline will be executed. So I have a simple error here. Yeah, I just need to change the name of the container that we use to run the npm run lint command. So hopefully this time it should be working. Yeah, there is a repository. So you have this repository which is responsible for deploying the Jenkins cluster and Sonarcube and all the CI architecture. And then there is this repository in which you have all the source code of the web application that we have trying to integrate with Jenkins. And also you find the Jenkins file and Docker files. So I'll be posting these two URLs on the Twitch feed just after finishing the integration of the app. So let's go back to Jenkins. So as you can see, the build stage has been successful, and then we went to the push stage. And on this push stage, we have tagged the image with the registry URI, and then we defined the commit ID as a tag, and then we used the docker push command to push the image to the Elastic Container Registry. So we can check that by going to the repository, and as you can see, we have our new image. So what you can do for advanced usage is configure your Elastic Container Registry to scan the image automatically. So I didn't enable that when I have created the repository the first time, but you can always do that manually by clicking on the scan button. So as you can see, the scan status is on progress. So it should take a few seconds for the scan process to be finished. And the advantage of using the scan is the ability to detect security vulnerabilities on your Docker images. So it's very recommended to scan your Docker images before deploying them to production. So here I have shown you how to do that with the Elastic Container Registry, but there is a lot of open source tools and also paid softwares on the markets that allows you to do that. So as you can see, there is a low vulnerability, and you have here the name of the SVE that describe the vulnerability. There is also another open source project that you can use, which I have been covering on my book, which called it Ensure Engine. So you can simply set up this project on your server, and then you can install the Ensure plugin on Jenkins to interact with. So the name of the plugin is the Ensure Container Image, and as you can see, basically this plugin will interact with the Ensure engine, and the Ensure engine is an open source project. It maintains a public database with all the public security vulnerabilities that has been detected, so that way you can inject security into your CI/CD pipeline to analyze your Docker images before pushing them to your Docker registry, and even better, before deploying them to your environment. So for this demo, I didn't cover how you can do that, but on my book, you will find a step-by-step guide on how you can achieve that with an open source tools like Ensure. So let me go back to the pipeline. So as you can see, for now, we have pushed the image. So the last stage we need to do is to deploy our application. So for now, we have achieved continuous integration. So basically, each time we push something to our GitHub repository, so each time we add a new feature to the application, an event will be triggering the pipeline, and will be running all the unit tests, compiling and building the static assets, and then building the image and pushing the image to a remote repository. So to achieve continuous deployment, we'll be adding another stage, and let's call it deploy. And this stage will basically use the AWS CLI to push the static assets that has been built by the npm run build command to an S3 bucket. So because I'm using AWS, I will be using S3. So S3 basically has a feature that allows you to enable static website hosting. So I will be creating a bucket for that. So I will be calling it movies aggregator, let's say demo. Now I will go to this bucket, and first I need to enable static website hosting. So the index document will be index.html. For the error documents, because we are using React, and React, it's like other frameworks like Vue.js, Angular, it's a single page application. It's a framework that allows you to build single page applications. So basically the routing mechanism is done at the index.html level. So the error document will be also index.html. That way we allow and we let React to manage the routing mechanism. So now we have this URL that we can use to access our application. So for now, the bucket is empty, and we need also to allow public access on the bucket. Then we need to define a bucket policy to allow people to see the index.html and all the assets. So this policy will be H3 bucket policy. The principal will be everyone, and the action is get object. So basically, when you go to this URL, on the background, you will be just calling the get object command. So we need to allow everyone to call the get object command on the H3 bucket. So we need just to copy the Amazon resource name of the bucket and allow all the files to be served with the get object command. Now, if I click on generate policy, I will copy this policy and go back once again and set it here. So now we have our bucket ready to be used. So as you can see, for now it's still empty. So now instead of having the wrong permission error, now we have 404 not found error message. So we can fix that by pushing our images, our static files to this bucket. So once again, I will be going to the directory of the project, and I will create another Dockerfile. I will call it Dockerfile.release, and basically this Dockerfile.release will simply have the same structure as the Dockerfile, and we'll be using once again the multi-stage feature. However, this time for the second stage, we'll be using the AWS CLI official image. For the version name, you can find it on Docker Hub. So I will be using the 2.1.22, and then I will define a working directory, and then I will copy the assets from the first stage to the current directory. Then I will be using the AWS S3 copy command to copy all the files from the build folder to the bucket that we have created. Now I need to go back to my Jenkins file and then need to type docker build command. So we will give a different name to the release Docker image, and because we are using a different Dockerfile naming, so I will need to provide this second parameter, and then I define the context. So now if we push this, our application should be deployed to the S3 bucket. So as you can see, a new event has been triggered. So all the stages of the pipeline will be triggered. This time it should be faster because we are using the caching layer of Docker. And hopefully at the end of the pipeline, the files will be pushed to the S3 bucket. So the Docker build is being executed. Now the image has been pushed. As you can see, now we are building the Docker image, which will run the AWS S3 command. So as you can see, this is the command that has been built. Now if I go back to the object sections, As you can see, my files has been pushed. So now if I refresh this page, I should have my web application, and we can test it out by typing a name of a movie. So as you can see, our application is working as expected. So basically, this is how you can define a basic CI/CD pipeline for your React web application on AWS using Jenkins. So was a basic example. If you want to learn about advanced stuff, make sure to check out my new book on mining called it Pipeline as Code. So you have a discount code that you can use to have some amount of discount on this book. And as I said earlier, you will find all the resources, all the Terraform templates and Docker files, as well as the code of the web application on the GitHub repository. So make sure that to check him out. And if you have any question, you can just drop me a message on my Twitter account or on my LinkedIn. So I will be sharing these URLs on the chat feed. So I hope you have learned something new, and I hope you have enjoyed this session. I hope to see you soon.